What's up, everybody, and welcome back to OpenStax Algebra and Trigonometry, Chapter 8, Practice Test. Let's do it. So for this one, we're meant to graph this function, and we're meant to determine the amplitude, period, and the equation for the midline. So let's do that now, and I'm going to pull on a graph here. So the amplitude is based on this constant in front, so the amplitude is 1/2 or 0.5. And the period for sine is typically 2 pi. There's no modifiers. There's no like constants like a 3 multiplying the x. There's no modifiers to the period. So the period is just going to be 2 pi. And then the equation of the midline, there's no vertical shift, right? There's no +7, -3, whatever. So then the midline is just at the normal spot, which is y equals 0, okay? All right, now let's put these in place. So the amplitude is that distance that we're going up and down from that midline. So we're going up by a half, down by a half, right? That's a half and negative a half. By the way, that's another reason why we keep the graph blank, so we can put in whatever we want. Normally you would say this is 1, this is 2, but then we'd have this tiny little graph, so this is gonna look much nicer. And then we have our period from 2 pi, so I'm gonna label this pi. And then now we got enough room for 2 nice periods. And then we got sine. Sine always starts right here at the origin without any modifications. There's no phase shift, there's no vertical shift, so it's gonna start there. And then typically it goes up, then back down, and then back up. And it goes back to that starting point at the end of the period. That's what we want. And then going to the left, it's gonna do that same behavior, but sort of in reverse. We're gonna, instead of going up, we're gonna go down. Then we go back up, back down, okay? And now let's connect the dots. And that's how you graph it, boom, done. So for this one, we got an amplitude of 5 because it's that leading coefficient. We got our period of 2 pi because the period hasn't been modified. And we got a midline at y equals 0 because that hasn't been modified either by a plus or minus constant right here at the end, right? So here we have all our values. And I kind of drew it in, right? Here's a midline at y equals 0. And if we say this is 5 and this is -5, then there we got the amplitude up 5, down 5 from the midline. And so we got everything kind of set up. And then with the period being 2 pi, I'll just make this pi, make this 2 pi, and then we have enough room for 2 full periods. So typical with sine, we're starting at the origin because there's no plus or minus for a vertical shift or a phase shift. So we're starting right there. And then typically what we do with sine is we start by going up, then going back down, and then going back up. And how do I know it all kind of ties together nicely by this point? Because that's one full period, so it should repeat, right, by the period. And then going to the left, we do the opposite. We go down, up, and then down. Now let's connect the dots. And that's how you do it, boom, done. So for this one, we're gonna start by identifying the amplitude. Since there's nothing there, we're just gonna say the amplitude is 1, your standard amplitude. There is a minus here, which we'll deal with in a second. But then first, let's identify everything else. We have our typical period. It hasn't been modified, so it's 2 pi. Then we have our midline right here, and that's also the vertical shift. The midline is y equals 1. Okay, now we've already kind of drawn that in. And by the way, I've already marked this with that amplitude of going up 1, down 1, right? And now we can deal with this pi thirds. What is a pi thirds? When it's plus the x like that inside the argument, that's a phase shift. And since it's plus, it's actually going to the left by pi thirds, all right? So we have a period of 2 pi, and then we're going to the left by pi thirds. So because of the pi thirds phase shift, I'm gonna change the way that I sort of set this up. Like normally I'd say 4 spots would be pi. Here I'm gonna say 3 spots is pi. And the reason why, and then here's 2 pi, okay? So that would be enough room for 1 period, and then we go to the left, we got -pi, and we got -2 pi. The reason why I'm doing this because then each one of these spaces is pi thirds. So it's gonna be easier to graph than if I tried to do pi thirds and it's split into pi fourths, right? So that's the beauty of leaving this graph blank. You can set it up however you want to make it as easy as possible. So normally cosine starts at the high point. But now we have to discuss that minus because that flips it across the midline. So now it's starting at the low point. And then normally it would start here right on the y-axis, but again, now we got that phase shift of pi thirds, so we move it back 1 spot. And there we go. Now we got everything we need. We're starting at a low point here. It's going to return to the low point in the period, meaning in 2 pi. So 1, 2 pi, it's going to return to the low. 1, 2 pi, it's going to return to the low. In between these low points, it's going to be at the high point. Same with these 2 points, right? And then in between the high and the low, it's going to be right in the middle right here. Now we got all these great points. Let's connect the dots. And that's how you do it. Boom, done. So for this one, let's start with the amplitude, which is this value in front, which is 3. There's no vertical shift, so the midline is going to be at the normal spot, which is y equals 0. Now we get to this argument. So what I got to do is I got to actually factor out that 1/3 to know everything I need to know about the period. So I'm going to factor out the 1/3 and the phase shift, by the way. So I factor out the 1/3, and it's like dividing this by 1/3, which is like multiplying it by 3. So it's x minus 15 pi sixth, or 5 pi over 2. Okay, now we have enough information. So the period is typically 2 pi, but I have to divide it by 1/3. I have to divide it by this coefficient. So the new period is 2 pi divided by 1/3, which is like multiplying by 3. So it's 6 pi. And then here's the phase shift. And the phase shift is going 5 pi halves to the right because it's minus. And by the way, 5 pi halves, same as 2.5 pi, if you want to think about it that way. So now I'm just going to make it like this is 3 pi and this is 6 pi and the same going to the left. That's enough for 2 full periods. And by the way, cosine normally starts at the high point, but now we have to take into consideration this phase shift. And the phase shift has gone 2.5 pi to the right. So I'm going to go 1, 2, 2.5. So there's that new high point. And then it's going to repeat every period at the high point. So go 1, 2, 3, 1, 2, 3. That's 6 pi. That's the period. And then going to the left, 1, 2, 3, 1, 2, 3 over here. And in between these high points, we have the low points. Boom. And we also have one in between here, here. And in between the highs and the lows, we have the midpoints here, 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 and here. And now let's connect the dots. And that's how you graph it. Boom. Done. So for this one, we're graphing tangent, and while we don't really have an amplitude for tangent, we can call that a stretching factor. So we have a stretching factor of 2. We have a midline occurring here at y equals 2 because that's the vertical shift. We have a typical period for tangent of pi, and that's not being altered, so that's the same. But then we have this, which is a phase shift, and the phase shift is going to the right by 7 pi 6, which is just over pi, right? 1 pi and 1/6 of pi. Okay, so I basically set it up like this, and the reason why is because since this is a shift of 7 pi 6, I made it into 6 spots equals pi, so that's 1/6 pi, 2/6 pi, etc. Now normally tangent starts right at the midline and on the y-axis, but again we're shifting to the right by 7 pi 6, so this spot can go 1, 2, 3, 4, 5, 6, 7 right here. And then that means we have vertical asymptotes, half a period to the left, half a period to the right. So we'll do the half a period to the left. And again, half a period is 3 spots to the left. That's pi halves. And then another 6 spots, we're going to have another vertical asymptote. And then we're going to have one more that we're going to be able to fit on here right here. And in between all of these on that midline, we're going to have a point. Now, typically, tangent goes up to the right, down to the left. But now we look at that negative, and that negative flips it. So now we go down to the right, up to the left. And now we have to consider that stretching factor. So normally I'd go down by 1 halfway in between here and the asymptote. But since it says a stretching factor of 2, I'm going to go down 2. Okay, so we go halfway here, and we go down 2. Halfway here, we go up 2. And now we connect the dots. And last but not least, to get the equation of the asymptotes, you can see we got one here at x equals 2 pi thirds, and then they repeat every pi, right? Because 6 of these spaces is pi. So then we'd say plus pi k, where k is any integer. That's how you do it. Boom, done. So for this one, I'm going to treat this as if it were 5 sine of 3x, okay? Because cosecant and sine are related. They're inverses of each other. So if we graph 5 sine of 3x, we can use that to graph the cosecant, 5 cosecant 3x, all right? So first of all, for sine, we have an amplitude of 5. Obviously, for cosecant, it's not going to be an amplitude. We can consider it maybe like a stretching factor or something, but there is no amplitude for cosecant. But for sine, we have an amplitude of 5. Now, typically, we have a period of 2 pi, but here there's a coefficient in front of the x, which means the period is now 2 pi divided by that coefficient, so it's 2 pi thirds. And then last but not least, the midline is going to be at y equals 0 because we haven't modified it with any vertical shift, so it's going to be at y equals 0. So now we have enough to sketch this out. So now I got the midline sketched out. I got the top and the bottom because it's an amplitude of 5, so it goes up 5, down 5. And now I can graph this sine function because sine usually starts right here on the midline and on the y-axis. And then to the end of the period at 2 pi thirds, it's going to come back to the center line, and it's going to be in the middle, at the middle of those 2 points as well. And then typically sine goes up, down, down, up. And then to the left, it's the opposite, down, up, down, like so. And the only way that would be flipped is if we had a negative in front, but we don't, so now let's connect the dots. So this is the sine function, but now we want the cosecant function. And this is gonna help us get the cosecant function because first we know where the vertical asymptotes are. The vertical asymptotes are gonna exist everywhere the sine function hits the midline. So for example, we have one here at 2 pi thirds, we have one here at pi thirds, and so on and so forth. Next, we're gonna look at every max point here, and we're gonna draw an upward facing parabola within those vertical asymptotes, and do the same thing at every minimum, but have a downward facing parabola, again, within those vertical asymptotes, like so as well. And the last thing we need is an equation for the asymptotes, and we can find that because like I can see one here at 0, pi thirds, 2 pi thirds. So they're occurring at every pi third. So we could say pi thirds times k, where k is any integer, right? We got 1 pi thirds, 2 pi thirds, negative 1 pi thirds, negative 2 pi thirds, so on and so forth. So that's how you do it, done. So for this one, I'm going to start by drawing in the same function, but I'm replacing cosecant with sine because cosecant and sine are related. They're both inverses of each other. So for sine, we have an amplitude of 2. Of course, we don't have an amplitude for cosecant. There's no amplitude, okay? And we have a midline right here. The midline is at -3. I already drew that in, y equals -3. And then we have this value, which is our phase shift. And it's saying a phase shift of pi fourths. And since it's plus, it's going to the left by pi fourths. And also we have our period, which is the standard period. Nothing's been modified. And the standard period for sine is 2 pi. So that's going to be the period here. Now let's put all this into the graph. So I've chosen to label the x-axis with pi and 2 pi for 2 reasons, right? 1, that's 2 full periods. 2, the pi fourths to the left, if this is 1 pi fourth, 2 pi fourth, 3 pi fourths, and then pi. That's going to be beautiful. That's going to make it easy to shift. Okay, now sine typically starts right here on the midline and on the y-axis. But again, we're shifting pi fourths to the left, so we're coming here, all right? And then now we can start to plot this out because we have a full period 8 away, right, for a full 2 pi. So it's going to come back here after a full period. It's going to come back to the middle after halfway too. And then going to the left, it's going to hit that halfway point here and here. And now to graph the rest of the points from the starting point, which normally is here, but it's shifted back. It goes up to the top, down, down, back up, and then going left, we go the opposite, down, up, and then back down. Now let's connect the dots. So this is the sine function, but now we're going to use this to get the cosecant function. So the way that this is going to help us is first, I'm going to draw in vertical asymptotes for cosecant wherever this sine function is hitting the midline. So here, as well as here, which is 3 pi fourths, and here is negative pi fourths, and so on and so forth. And now we're going to draw the actual cosecant function, and we're going to take every max point of the sine function and draw an upward facing parabola like so. And remember, we stay within the confines of these vertical asymptotes. And then likewise going down, we do these downward facing parabolas. And last but not least, to get the equation of the asymptotes here, right? We're having one occur at 3 pi fourths, and then it's occurring every pi away, right? So 3 pi fourths plus pi k, where k is any integer. That's how you do it. Boom, done. So for this one, we're meant to determine the amplitude, period, and midline. Okay, so let's look at this graph. So I see the midline is right here at y equals 0. That's our midline. And then the amplitude, it looks like it's going up and down by 2. So I'm going to say the amplitude is 2. And then we got a period. It looks like it's repeating from 0 to 2, right? It's kind of going down, up, and then back down. It's completing the cycle. So the period is also exactly 2. Now, typically, the period is 2 pi. And then when we divide it by the b, which we're going to get to in a second, where that goes in the equation, we get the actual period, which in this case is 2, which means if I multiply this over here and divide it by 2 while simultaneously multiplying by b, I get b equals 2 pi over 2, which is b equals pi. That goes in the equation, and I'm going to show you how now. So if we have the function f of x equals, we start with the amplitude and 2 sine, and we notice that it goes down instead of up first. That's going to mean we have a negative here, okay? So we need a negative 2, and then this is where that b value goes. The b value goes inside of here as a coefficient in front of the x. So sine pi x, and the midline's at 0, so there's no vertical shift. And by the way, just to clarify, this is correct, but I'm going to give you one alternative function because this is how they put it in the back of the book, and it's the exact same, okay? They made it 2 sine, and then what they did was they had a horizontal shift to the right by 1, okay? So this is what they have in the back of the book, and then they didn't negate the 2. It ends up being the same thing. Now, you can plug and chug different values in and you can confirm that. But if you look at what they did, they left it as going up, right? The typical thing where it goes up and then back like this. And then with that -1, it shifts it to the right by 1. So that's why it kind of still lines up. So anyways, both of these functions are correct. So here we're meant to find the amplitude, period, phase shift, and midline. And the first thing I'm going to do is I'm going to actually factor the pi 6 out from this entire thing in here, and that's going to make everything a lot easier. So when I factor the pi 6 out, I have the x left over, and then it's basically like I'm dividing pi by pi 6, which is the same as multiplying pi by 6 over pi, and that gives you 6, okay? And if you're not sure why exactly that works, think about it. If you redistribute it, you end up with pi. 6 times pi 6 is pi, so you know that's correct. And then we have -3, okay? And since there's no leading coefficient in front of the sign, the amplitude is 1, all right? The period is typically 2 pi, but now it's going to be 2 pi divided by that coefficient, so 2 pi divided by pi 6, which is the same as 2 pi times the reciprocal of that, which is 6 over pi. These cancel out, and you get a period of 12. The phase shift is this in here. It's adding 6, so that means it's going 6 to the left, or you might be able to also say phase shift of -6. Either are correct. And last but not least, we got the midline. That's the vertical shift, and the midline is going to occur at y equals -3. Would be at y equals 0 if we didn't have the vertical shift, but now it's at y equals -3. That's how you do it. Done. The outside temperature over the course of a day can be modeled as a sinusoidal function. Suppose you know that the temperature is at 68 at midnight, and the high and low temperatures during the day are 80 high and 56 low, respectively. Assuming t is a number of hours since midnight, find a function for the temperature d in terms of t. So what they're kind of insinuating here, they're not saying it exactly, but this looks like the exact middle temperature. And we can kind of confirm that because it's 12 below this and 12 above this. So since the midline is usually a constant at the end, I'm going to say whatever it is, it's going to be plus 68. So that's going to be our midline. And then since I'm already telling you that it's going 12 up and 12 down, 12 is the amplitude. So I already know that I need 12 as a leading coefficient in front of sine. Now, just so you can kind of see what this is really looking like as we're kind of mapping it out here, we're seeing that it's going up. This is a typical sine function, by the way, right? Starting at the midline, going up, down, down, and then back up. And this 24 is coming back to midnight. This would be noon right here. This would be 6 p.m. here. This would be 6 a.m. here, okay? But this is a little odd, right? This doesn't make sense because 6 a.m., that's the morning. That's going to be actually the cold time. So what I would say would make more sense is if we actually negated this function, put a negative in front, because if we put a negative, it flips it, and that means the coldest time will be at 6 a.m. It's going to come back here at noon. Then the high temperature will be at the end of the evening. Not exactly totally accurate, right? Usually the hottest part of the day is like 2 or 3 o'clock, but kind of accurate. And then it's going to come back down to 68 at midnight. So now we're going down to 56 here and then up back to 80. And then again, the period is supposed to be 24 hours. And the way we get the period is we do 2 pi divided by a b term, that's going to go in the function eventually, is equal to 24. So to solve for b, divide by 24, multiply by b equals 2 pi over 24, which is the same as pi over 12. So that's the constant that needs to go in here, pi over 12, and then the x. And sorry, they wanted this in terms of t, so it should actually be t here. I know they have it as an x in the answer book, but it should be t. They also have these flipped, but it's the exact same thing. So I like this better because this sticks more to the typical format of a sinusoidal function. So that's how you do it. Done. So for this one, we're meant to find the period and the horizontal shift. So the first thing I'm going to do to find that is I'm going to factor out the 6 from the inside. So I pull the 6 out, and now I have x plus 7 left on the inside. Because if I redistribute this, I get 6x plus 42, and that's what we have. So I know I factored it correctly. So the period of tangent is typically pi, and to get the new period, I just divide by this coefficient here. So now the new period is pi over 6. And then the horizontal shift is from this value after you've factored. So you could say the horizontal shift, you can either say it's -7, or you could say it's 7 to the left, right? When it's plus, it's to the left. When it's minus, it's to the right. So that's how you do it. Boom, done. So we're going to write this as a secant function. So before I do that, I'm actually going to connect the mins and the maxes, and I'm going to think about this as a cosine function first. So for this cosine function, it looks like the period from the max to the max is exactly 2. And it also looks like there's no phase shift, right? It's supposed to start on the max, so we're going to say the phase shift is actually none. Now, because the period is normally 2 pi, and we divide it by our b term, which is going to go in the equation to get the actual period, which in this case is 2, I can solve for b. I know that if I divide by 2 and multiply by b, I get b equals 2 pi over 2, which means b equals pi. So if I were to write my equation for this cosine function, it would be f of x equals, and again, we got an amplitude by the way of 1. It's going up 1, down 1. So I don't need a coefficient in front of the cosine. So I say cosine of, and then there's my b term is pi of pi x. Now, since that would be the cosine function, the corresponding secant function, which is drawn here in blue, it's going to be f of x, and I just replace the cosine with secant, and then it's the same, pi x, and all this stuff is good, right? We have no phase shift, we have a period of 2, that's how you do it, done. If secant x is equal to 4, find the secant of negative x. So remember, secant is related to cosine, okay? And cosine, the symmetry property of cosine is such that cosine of negative x is the same as cosine of x. They're the exact same. So the same property is true here. So secant of negative x is the same as secant of x, which we already know is 4. So the answer is 4. Boom, done. So this one says to graph this on the following domains. So let's do that in Desmos now, and then we can look at these questions. So here is the function from 0 to 1, and this is how it looks like. Now let's change it to include from 0 to 3. And so here it is, it's condensed much more. It looks kind of more dense. So, I mean, to me, I don't think they look that different. It's the same function. It still has this amplitude of 0.02, right? Going up 0.02, down 0.02, still a center line or midline at y equals 0. So that's all. It's basically, you're just seeing more periods, more cycles because it's a bigger domain. So that explains it. Boom, done. So this says, what is the largest possible value for this function? So the midline, because there's no vertical shift, right? The midline is going to be at y equals 0. So to get the biggest possible max, we have to look at the amplitude, which is this constant here, the amplitude of 3/5, and we add it to the midline. That's going to give us our highest point. So 3/5 plus 0 is 3/5. So that's the largest value. Boom, done. Where is the function increasing on the interval from 0 to 2 pi? So I'm going to graph this in Desmos, and then I'm going to show you where it's increasing. And again, increasing means where does it have a positive slope? So let's check it out. So here's where you can see, right? Everywhere where the slope is positive, meaning like this stretch, right? In these intervals, that's where it's going to be increasing. Now, in the back of the book, they've done decimal approximations. I'm going to actually give you the real values in terms of pi, just so you can see. So here are all the values, and in red is what I've highlighted the segments with an increasing, aka positive slope. So again, these are the intervals in the exact format. You can see the rounded intervals or the approximate intervals in the back of the book. That's how you do it. Done. So we got a cosine curve with an amplitude of 2, a period of pi 6, and a phase shift of 2 parts, right? This is the vertical shift, and that's the shift to the left. What we normally call the phase shift. We're going to the left by pi fourths. So let's write out the function first. So since we have an amplitude of 2, let's start with that in the front. Then we have cosine, and then the period normally is 2 pi. But we're getting pi 6. So what do we divide 2 pi by, right? What do we divide 2 pi by to get pi over 6? Well, it's going to be 12 because 2 pi over 12 is pi 6. So we know we have a coefficient of 12 like this. Now we throw in that phase shift. Again, it's going to the left by pi fourths. That means we actually add pi fourths in here. And then the last thing we do is we do the plus 3, right? Because that's a vertical shift up by 3. So I just kind of move the graph around so we have more room. Okay, now let's draw the center line. So we have a midline or center line at y equals 3 because that's coming out here. Then we're going up by 2 and down by 2. That's the amplitude. So the lowest it'll go as 1, the highest it will go as 5, and the midpoint is at 3 here. And now normally cosine starts right here at the max. But because of this horizontal shift by pi fourths to the left, we're moving it pi fourths to the left. But now we have to label the x-axis. We haven't done that yet. So the way I'm going to do it is I'm going to say that this is negative pi 12ths and this is positive pi 12ths. And I like using pi 12ths because I can use pi fourths and pi 6. 6 and 4 are both factors of 12. So that's going to make it easier. This is 2 pi 12ths, which is the same as pi 6, negative, of course. And then this would be negative 3 pi 12ths, which is the same as negative pi fourths. And then this would be negative 4 pi 12ths, which is the same as negative pi thirds. And then going to the right, we'd have the same thing. So now let's implement this phase shift. We're going to the left by pi fourths. And then now let's do our typical function. Again, remembering that pi 6 is the period, and pi 6 is this distance, right? It's basically 4 squares on the way I've graphed it. So it's going to return back to the max after 4, back to the max after 4, back to the max after 4. And then in between these max points, I'm going to the minimum. I'm going to the minimum, and I'm going to the minimum. And then in between the max and min, I'm hitting that midline perfectly in the middle, right? So we've got these points. Now let's connect the dots, and that's how you do it. Boom, done. So for this one, it says to graph it and then note any periodic behavior. So let's graph it in Desmos now. So as we graph it, it does definitely look periodic, right? It looks like it repeats. It kind of cycles as we go through. And the actual period, it looks like it's going from negative pi halves to 3 pi halves to where it cycles. That's a distance of 2 pi. So I would say, yes, it's periodic because it does have that cycle. And the period is 2 pi, boom, done. So this one is asking to find arctangent of rad 3. So really the question is, where are we going to get a value of rad 3 on the unit circle? And for tangent, that's when y is over x, right? Like y over x. When is that going to give me rad 3? That's going to be when the y is rad 3 over 2 and the x is 1/2, because rad 3 over 2 divided by 1/2 is rad 3. So we've got a place here where it can happen and a place here, because the two negatives will cancel out, will also give me positive. But then we have to look at the range of arctangent, and the range of arctangent is from negative pi halves to pi halves. So here, so this is out, which means our only possible answer is there, pi thirds, boom, done. So this one we're finding arc cosine of sine of pi. So let's go inside out. First of all, what is sine of pi? Using the unit circle, here's pi. Sine is the corresponding y value. So that means we're now taking arc cosine of 0, that y value, right? Sine of pi is 0. So what is arc cosine of 0? We're trying to look to see any place on the unit circle where we have an x value of 0, okay? And what is that angle? That's what we're trying to find. So x value of 0 occurs here and here. So it's occurring at 3 pi halves and pi halves. But the thing is, the range for arc cosine is from 0 to pi, which means this is out of that range, and pi halves, therefore, is the only answer. Boom, done. So to do this problem, we actually have to draw a triangle. We can't use the unit circle. So we're going to start with this. And remember, this is saying arc sine of 1 minus 2x. But this is the same thing as saying sine of an angle, some unknown angle, is 1 minus 2x. And then in the triangle, we can call this angle theta right there. We can put it in. And remember, what is sine? Well, sine from SOHCAHTOA is sine of an angle is the opposite over adjacent, opposite side over adjacent side. Well, if sine of theta is 1 minus 2x, I can say the opposite side is 1 minus 2x, and then I can call the hypotenuse 1, because then opposite over hypotenuse is this, okay? So now we're in a good spot here. And now we can find the third side using Pythagorean's theorem, okay? I'll call this b. So I'll say 1 minus 2x squared, that can be a, plus b squared equals c squared, which is 1 squared, which is just 1. And then if we FOIL this one out, it's 1 minus 2x times itself, like this, 2 binomial. So we have to FOIL. So I get 1 minus 2x, that's minus 4x. And then negative 2x times negative 2x is 4x squared. And then plus b squared equals 1. These two ones are going to cancel out. Then I'm going to say b squared equals, I'm going to subtract this and this from both sides. So now I move that over, it becomes positive 4x, negative 4x squared. I'm going to take the square root of both sides, and we get b equals the square root of 4x minus 4x squared. So that's B. Last but not least, we need cosine of this angle, which is theta. So cosine is adjacent over hypotenuse, which is just square root of 4x minus 4x squared. And by the way, in the answers, just FYI, they left it as 1 minus 2x squared. They didn't FOIL this out, right? So they left it like this. But you'll see if you FOIL it out, you get the exact same thing. Again, the ones cancel out, and then you're left with negative 4x, but that negative is going to make it positive 4x, and then you're going to left with positive 4x squared, but that negative will make it negative. So it's the same thing, but this is the simplified version. Done. So for this one, we can't use the unit circle, but we can make a triangle here. And remember, this is saying arctangent of x squared, which is the same as saying tangent of some angle is x squared. And I can say that angle theta, I can put it here in the triangle. And what is tangent based on SOHCAHTOA? Tangent is opposite over adjacent. So tangent of theta is x squared, so I can say the opposite side is x squared. I can say the adjacent side is 1, because opposite over adjacent will be x squared. Now I can use Pythagorean's theorem to find c, the hypotenuse, so I can say 1 squared plus x squared squared, which is x to the 4th, equals c squared. So then that's 1 plus x to the 4th equals c squared. Take the square root of both sides. C equals the square root of 1 plus x to the 4th. Last but not least, let's take cosine of theta, which is adjacent over hypotenuse. So it's 1 over the square root of 1 plus x to the 4th. Boom, done. So for this one, we're meant to find cosecant of t, knowing that sine of t is equal to x over x plus 1. And the relationship between these two is their inverses, aka reciprocals of each other. So cosecant of t, therefore, would be the reciprocal of this, which is x plus 1 over x. Boom, done. So here we're trying to figure out if this is indeed true. And it kind of looks at, on its face that it makes sense that it's correct, because arc sine and sine, they'd kind of cancel out and you'd be left with 5 pi 6. But let's look at the unit circle to see if this is indeed true. So first we have sine of 5 pi 6, and here's 5 pi 6. Sine would be 1/2, okay? Now we're going to take arc sine of this value of 1/2. And if we take arc sine, we're really saying, hey, where on the unit circle do we have a y value of 1/2? We have it here and here, okay, both spots. So do we come back and do we get 5 pi 6? No, we do not, because if you remember, the range of arc sine is from negative pi halves to pi halves. It's this side. So what would you get when you're taking arc sine of 1/2? You get pi 6, not 5 pi 6, okay? And also, we could have known right off the bat that this is outside the range. So this has to be false. Boom, done. The grade of a road is 7%, which means that for every horizontal distance of 100 feet, the vertical rise is 7. Find the angle that the road makes with the horizontal in radians. So if we were to draw this out, this would be going up by 7 feet for every 100 feet that go across. And we're trying to find this angle, theta, that it's making with the horizontal down here, okay? And the way that I would start something like this is just going back to SOHCAHTOA, and don't even think about arcsine, arccosine, or arctangent yet. Just think, which of these three functions, sine, cosine, or tangent, can we use with the values given? Well, I can make a relationship, aka an equation, with theta using the opposite and adjacent with the tangent function, right? So we already know we're going to start with tangent of theta equals opposite over adjacent. And then now to solve for theta, we have to isolate it. So we have to take arctangent of both sides. That'll cancel out the tangent here. And then we take arctangent of 7 over 100, and we'll do that in Desmos now. So when we round up to the nearest hundredth, it's 0.07. So we'll say approximately 0.07 radians. Boom, done. I hope you guys enjoyed this video, and if you did, please click that like button. And if you want to see more from the Scalar Learning channel, make sure to click subscribe. Thank you guys so much for joining, and I'll see you in the next video. Take it easy.